This is lesson 4.8, least common multiple. Use cubes to build the first row of each prism as shown. Add a second row to each prism. Record the total number of cubes used in a table like the one shown below. Add rows until each prism has 4 rows. Okay, so we add 4 here to get 8. We add 6 here to get 12. We add 4 here to get 12. We add 6 here to get 18. We add 4 here to get 16. We add 6 here to get 24. Describe 2 prisms that have the same number of cubes. Well, let's see. If we had prism B with 2 rows, we would have 12 cubes. If we had prism A with 3 rows, we would have 12 cubes. 3 times 4 here, 2 times 6 here. If you keep adding rows, will the 2 prisms have the same number of cubes again? Well, let's see. If we continue, we've got 5, 6, 7, 8, 9, 10. Let's go another 5, see what happens. So we have 20 here, 30 here, 24 here, 36 here, 28 here, 42 here, 32 here, 48 here, 36 here, and 54 here. We can see here that we have 36 cubes here again when we have 9 rows of 4 or 6 rows of 6. A multiple is the product of a number and any whole number. The least common multiple, or LCM, of 2 or more numbers is the least of their common multiples excluding 0. Method number 1, to find the least common multiple of 6 and 10, we simply list multiples of 6 until we come with a number that is also a multiple of 10. Generally, you'll list 5, see what happens. List 5 of the smaller number, and then list multiples of the larger number until you get a common multiple. In this case, it doesn't take very long to come up with 30, which is a multiple of both 6 and 10. It is the smallest common multiple, therefore is the least common multiple. We could also use prime factorization. The least common multiple is the least product that contains the prime factors of each number. So the LCM of 6 and 10 is 2 times 3 times 5. Notice it doesn't contain all the 2's. It's all the prime factors of each number, the most times they occur. We'll show you more examples of that. Find the LCM of 45 and 75. The prime factorization of 45 is 3 times 3 times 5, or 3 squared times 5. The prime factorization of 75 is 3 times 5 times 5. So in this case, the most 3's we have is 2, and the most 5's we have is 2. That gives us 9 times 25, or 225. The least common multiple is the product of the prime factors 3 and 5, with each one raised to the highest power it occurs in either prime factorization. Each of the prime factors, the most times it occurs. Okay, let's try 3 and 12. We're going to do this the old-fashioned way, just listing multiples. 3, 6, 9, 12. Our first multiple here is 12. So our least common multiple is 12. We'll do prime factorization for 10 and 12. 10 is 2 times 5. 12 is 2 times 2 times 3. So we're going to use 2 2's, a 3, and a 5. 2 times 2 times 3 times 5. which is 4 times 15, which is 60. 25 and 30. Again, we'll do prime factorization. 25 is 5 times 5. 30 is 2 times 3 times 5. So both of these 5s, this 2 and this 3. So 2 times 3 times 5 times 5. 25 times 6 is 150, which is our least common multiple. Ling needs to buy paper plates, napkins, and cups for a party. Plates come in packages of 12, napkins come in packages of 16, and cups come in packages of 8. What is the least number of packages she will have to buy if she wants to have the same number of plates, napkins, and cups? What she's doing is finding the least common multiple of 8, 12, and 16. 8 is 2 to the third. 12 is 2 squared times 3. 16 is 2 to the fourth. So we're going to use 2 to the fourth the most times it occurs. That's the most 2's, and the 3. So 2 to the fourth is 16 times 3 is 48. Now, because they come 8 cups in a package, it's 48 divided by 8 gives us 6 packages of cups. Plates are 12 to a package, so 48 divided by 12 is 4. Napkins are 16 to a package, so 48 divided by 16 is 3. So she needs to buy 6 packages of cups, 4 packages of plates, and 3 packages of napkins. Mr. Hernandez changes his car's oil every 3 months, rotates the tire every 6 months, and replaces the air filter once a year. So 3 months, 6 months, 12 months. If he completed all 3 tasks in April, what is the next month? He will again complete all 3 tasks. Well, let's see. Let's do this. 3, 6, 9, 12. 6, 12, and 12. 24. 18, 24. 15. 18, 21, 24. If he completed all 3 tasks in April, which is the next month, he will complete all 3 tasks again. Well, let's see, what do we got for common multiples? We've got 12, and we've got 24. So the next time he will complete all 3 tasks again is 1 year from now, or next April. Find the LCM of each set of numbers. 4 and 14. Prime factorization of 4 is 2 times 2. 14 is 2 times 7. So 2 times 2 times 7 is 28. 6 and 7. Well, 6 is a prime, or 7 is a prime, I'm sorry. So we would simply do 6 times 7, which is 42. Number 3, 12 and 15. 12 is 2 times 2 times 3. 15 is 3 times 5. So it's 2 times 2 times 3 times 5, or 15 times 4, which is 60. Number 4, 21 and 35. 21 is 3 times 7. 35 is 5 times 7. So 3 times 5 times 7, which is 21 times 5, or 105. Number 5. 3, 5, and 12. Well, 3 and 5 are prime, so I can't factor those. 12 is 2 times 2 times 3. So I've accounted for the 3. I simply have to multiply this times 5. And my least common multiple of those four numbers then is 15 times 4, which is 60. Number 6. 6, 14, and 21. 6 is 2 times 3. 14 is 2 times 7. 21 is 3 times 7. So I got to have a 2 and a 3 and a 7. So 2 times 3 times 7 is 42. The number of years per term for a U.S. president, senator, and representative is shown. Suppose a senator was elected in the presidential election of 2008. In what year will he or she campaign again during a presidential election year? Well, let's see, 4, 6, and 12. The senator was elected in the presidential election year of 2008. So he will be elected again in 2014. The president will be elected in 2012. And the representative will be elected in 2010. So 2016, 2020, 2012, 2020, 2026, 2014. I can see that if I continue these out, my answer is going to be 2020. The vocabulary for this lesson is multiple, the product of a number and any whole number. Least common multiple is the least of the common multiples of 2 or more numbers. In this example, the LCM of 2 and 3 is 6. At this point, you should quit the video. Go to my Moodle page, log in using your 6-digit student number and your password, which is the first 6 digits of your last name, and your 2-digit birth date.